Okay. So a while loop executes a statement while a given condition is true. Okay. It tests the condition before executing the loop body. Okay. So in while loop, we run a loop, or we run a particular code block unless and until a condition is true. Okay. So every loop is executed till a condition is true, and then it is terminated once the condition turns false. Okay. So we have saw how to do conditioning, how to do conditional statements. Okay. When we saw if and else statements and switch case statements. Okay. So same conditions we can use here, or we can use conditions, the mechanism of condition provided by the loops itself. Second type of loop is for loop or for each loop. So it executes a sequence of statements multiple times, and it abbreviates the code that manages the loop variable. So for loop generally is executable by using a loop variable. Okay, we'll see it practically when we see one example. Then do while loop, like a while statement, except that it tests the condition at the end of the loop body. Okay, so do while loop is a special loop. It executes the condition at the end. So it always makes sure that our code is executed at least once, even if the condition is false. Okay, so this is theory, but when we do practical, you will get a better idea of what all these loops are. So for loop executes a block of statements repeatedly until a specified condition is met. Okay. Until a specified condition is met, as and when the condition is false, the loop is ended or loop is terminated. Okay. So for example, see in this block diagram on the right hand side of the slide, first we have to initialize a variable in for loop. Okay, we have to initialize a variable, then we check the condition. Okay, then the condition is asserted, right? If condition is false, we exit the for loop. Okay, we exit the for loop. But if condition is true, we execute certain set of statements. Okay, see, we will not execute any set of statements if condition is false, even in the first iteration, right? But if say condition is true in first iteration, we execute few statements. We increment or decrement the loop variable, right? In for loop, we have loop variable. So we either increment or decrement it and retest the condition. Okay. If it is true, we again do the same thing, again increment or decrement, and then redo the condition, recheck the condition. If it is true again, and we do this cycle, we do this looping unless and until the condition is false. Okay. And you see, what are we doing when we are looping? When we are going through this round and when we are going through this this round loop, we are every time we are coming to these statements, right? So we are executing the statements again and again with every iteration of loop. Okay. So this one cycle is known as one iteration. So what we will do, we will execute the loop where we'll execute the statements with every iteration of the loop. Okay. So let us have the walkthrough, or let us look at the code. Okay. So for loop code. So this is the basic syntax of for loop. It starts with the keyword for. Okay. For is a keyword, FOR, for. And then the parenthesis, okay, the round brackets. Okay, then we have the parenthesis, and in the parenthesis we have three items. Okay, we have three things that are there in the for loop. Okay, this is a point to remember. In a for loop, in the parenthesis, there are three items in the parenthesis. There are three things required. There are three items required in the for loop for it to be executed. The first item is the loop variable. Okay, so you can see integer I. Generally, we keep it as integer. So integer I is a loop variable. Okay, second item. So these items are separated by a semicolon. So this is the first item, int I is equal to 1. see what we are doing. We are just initializing a loop variable. Okay. Second item, we will check a condition. So second item between the semicolons is the condition. Okay. So condition specifies till when we have to run this loop. Okay. Terminating condition, this is, we are specifying here when my loop will terminate. Okay, because otherwise, you know, the loop will keep on going forever, right? It will be an infinite loop. So we have to specify a logical condition which is met and the loop is terminated. Okay, then third thing is the process we undertake on the loop variable process. Okay, some operation, we are I plus plus is going back to the operators class, this is incrementing the value of I by 1. Okay, so these are three things in the for loop. Okay, and they are in the parenthesis. Okay, so first thing is loop variable. Second thing is loop terminating condition. Okay, so as and when this condition is true, loop terminates. Okay, terminates means it goes to the end of the block. End of loop block. Okay, third thing is the operation on loop variable. Okay, so either we increment or decrement loop variable. Okay, so in this example, you can see initially the value of I is 1, correct? We are assigning the value of I as 1, correct? In the initialization section. Then we are checking a condition. Okay, so in first iteration, we are checking is 1 less than 3, correct? So sorry, I wrote it wrong here. If condition is false, the loop terminates. So first iteration is 1 less than 3. Answer is true. We will go inside loop. When we say go inside loop, we will come inside this curly bracket and execute whatever is between this curly bracket open and this curly bracket end. Okay, whatever is there. For this case, there is only one statement here, which is printing a number. Okay, so output, what will be the output here? Output will be number colon 1, correct? Because number is there plus I, the current value of I is 1. Okay, from here, correct? After all lines are done, just before the code block is ended, what Java virtual machine will do, it will do this operation. Okay, it is a post processing operation, right? It is done just before exiting the code block or just before entering the code block. So it will do the value of I as I plus plus. Okay, so the value is 1 right now. 1 will be converted to 1 plus 1, which will be equal to 2. Okay, so the new value of I will be 2. Okay, now again, now this time it will not initialize. Okay, because initialization is one time operation. Okay, so this was initialization. It was one time operation. Carried in first iteration only. Okay, so first iteration we have already initialized. We won't initialize it again in the second iteration, but we will check the condition. Okay, so on the second iteration, we'll check the condition. So what is our condition? Is 2 greater than 3? Answer is true. Correct. True. 2 is less than 3, right? Answer is true. Again, go inside the loop. Okay, what will be printed now? The thing that will be printed is number colon 2, because the value of I is 2 now. Okay. Again, I would be incremented by 1. Again, we will check the condition, third iteration. Check condition. 3 is equal to 3. So is 3 less than 3? The answer is no. So condition iterated is false and loop terminates. Okay. So this is the life cycle of a loop. Now you see what we did. We executed the statement or the code block which is inside the loop body. So this is loop body between the curly braces. We executed this statement number of times. Okay. So my requirement was to execute it 2 times. So I did it like this. Okay. So based on requirement, we can change these things over. Okay. So when we say I is equal to 1, we are initialization loop starts at this value. First condition that is checked is whether 1 is less than or equal to 3. Okay. So if condition is true, we'll print and I is incremented by 1 every time. Okay. Yeah. So see, when I is 1, it will print number 1. I will be incremented by 1. Okay. Second time, there is an error in the slide. So you have to read the middle box, this one as looping second time. Okay. Because it is looping second time. So on looping second time, I is equal to 2 till number 2. I will be incremented by 1. Okay. Then third time, again, this is wrong. You have to read it looping third time. I is equal to 3. I is less than 3. Condition not met. Loop is not entered. When we say loop is not entered, this code block between the curly braces will not be executed. Whatever is after this ending curly brace would be executed. Okay. I mean, that will be the regular code flow. But inside the curly braces, we have system.out.println number I. That block will not be executed. Okay. So initial numbers and the final values that we are expecting can be anything. Okay. So we need not have to initialize every loop variable by 1 or 0 or 2. Okay. It can be any number, right? Based on our programming requirement. So update can also be a minus or another other operator. Okay. So here we are incrementing it by 1. We can also do a reverse logic, like initialize it to 5, check whether 5 is greater than equal to 1 and decrement the 5 every time. Okay. So this loop will be executed till I becomes 0. Okay. Because we are using greater than equal to. So this loop will be executed for when I is 5, when I is 4, when I is 3, when I is 2, when I is 1. 5 times this loop will be executed. And when I is 0, the loop will be terminated in the 6th iteration. 5 iterations will be executed for this example, this one. So some loop executes 0 time as condition is never true. Okay. For example, see this example. Initializing, we are saying I is 10 and we are checking 10 is less than 5. So it is never true, right? 10 will always be greater than 5. And then this loop will be never executed. Okay. No matter what our logic is, it will never execute. It will terminate in the first iteration without executing any code of lines. Okay. So this is a incorrect way to define a loop. Okay. If we are defining it, we should have a clear requirement in mind that we need to run certain line of codes multiple times. Then only we go ahead and execute, process the loops. And some loops are infinite loops, right? So for example, we give a condition which will never be achieved. So every time the loop will be executed, okay, till eternity. Okay. So to do that, we have to, kill our Eclipse session or kill our Java session to terminate the program, right? Forcefully. Because gracefully it will never be end. Gracefully it will never end. For example, consider this loop. The last example, we are saying I is equal to 10 and I is greater than equal to 1, and then we are incrementing the value of I by 1, correct? So in the first iteration we will see that 10 is greater than 1, correct? So it will execute. Next iteration we will increment it by 1 because we are using plus plus operator. Okay, so it will increment to 1. 11 will always be greater to 1. 12 will always be greater to 1. Okay, so it will keep on incrementing the value of I, but that value will always remain greater than 1. Okay, fine. Let's do some practical. Number 2, program to print numbers using for loop. Okay, so I'll do this one. So we don't want to write, so there are two ways here, see. So there are two ways here, okay, to print the numbers from 1 to 10, okay. Like if you want to have this output, we can write 10 times system.out.println number :1, system.out.println number :2, right? We can do that, but that is a poor way of programming, right? Because there will be a lot of redundant code. And consider if I tell you to print, say, numbers till 10,000, so you will have 10,000 lines of code, right? So that will be a very average program, or it will be a bad program because it will have a lot of lines of codes, okay, and it can be a very complex program. So as a workaround, what we can do, we can use a loop, which is the correct way and proper way of achieving a situation where multiple times same code has to be executed. So we'll create a package, we'll say it com.loops. We'll write one class. We'll call it check for loop. Okay, so my goal is to print numbers like number 1, number 2, and so on till number 10. Okay, so this is my problem statement. Okay, so to do this, how I can achieve the solution? There are two ways. See, first way is to write a lot of redundant code, right? I can say that I will write number 1, then I'll do the same copy paste number 2, then I'll say copy paste number 3, and so on up to 10, right? But now imagine, that I give you assignment to write for 10,000 or 1 lakh or 5 lakh numbers, right? So that will be a very hectic, very difficult job, right? So how to simplify this job using a for loop? So I'll say for, okay, then I have 3 conditions. First is initialization, I is equal to 0, or so I is equal to 1 for simplicity. then we will need to have a condition. We'll need to run this loop 10 times. So we can say I is less than equal to 10. Okay, and then we can say I plus plus. And I opened, see here I opened the for block. Okay, so this is for block, this one. So I can say sys out number colon. So this part is going to be constant, right? For everything, for every statement, right? In my output, the only thing that is changing is the number. So I'll say plus I. See, this is the variable name, not inside double quotes. And this is my program. I'll run it. See, this is my console output, or this is my output of program. Okay. Now, if I say you that I want to run it for 1000 numbers or 100 numbers. So what you have to do, you have to simply change the condition and you have to run it. See how simple it was. Consider, writing sysout statements 90 more times. See, right? That will be a very difficult job. But due to loops, you can achieve these things very easily. See what our program did. Let us understand here once again. Let us walk through code once again. We initialize it to 1 in the first iteration. Okay, so this block is executed only in the first iteration. Okay, this item, there are 3 items, right? First item is executed only once, okay, for every loop. Second item is condition. This is executed for every iteration. Okay, and third item is increment the I. It is also executed for every iteration, right? So when in the first iteration it checks whether 1 is less than 10, it finds true, it executes this statement. Okay, second iteration again executes, third, fourth, up to 10 iterations it executes. On 11th iteration it finds I as 11. Okay, so it checks whether 11 is less than 10. In 11th iteration it finds that no, it is false. Correct? Is 11 less than or equal to 10? No is the answer. Condition is false. So loop terminates. This is not executed. See, we cannot see number 11 here, right? Sorry, let me run it again. So we do not see number 11 here, right? So now my program comes to end of this block. Okay, and it terminates. So if anything is written after this line, say here, so it will be printed after termination of loop. Say I say loop ended. See, this is okay. So this is end of for loop block. Correct? This is start of for loop block. Correct? So see, this line will be printed once after for loop has been executed for 10 times. So for loop has executed this line under 10 times. Okay. See, loop ended is only printed at the last. Okay. We can also print multiple statements here. For example, we need to check. We need to say loop. Every time we need to say loop executing now. So you might say loop executing now. Okay, just as soon as loop kicks in, we might need to print a message, right? That okay, going to this block, entering this, doing this, right? Anything. So if I run this, see, every time there are 2 statements now getting executed. First, loop executing now for every iteration. Second, the number is getting printed. Okay, so this is how we use for loops. There can be any number of statements here, there can be any number of statements, right? All these will be executed, okay, for multiple times. Okay, moving ahead, write a program to produce following output. Okay, so I'll write program 1, and then you can launch Eclipse by the time. You can see how I'm writing program 1. On similar lines, you can write the program 2. Okay, so what is my expectation? I want to print 30, 20, 10, 0, 10, minus 10, 20. Okay, yeah. So let me have a new class. Forloop Program 1. Okay, I'll name it Forloop Program 1. I'll have a main class here. Okay, so what is my expectation here? What I want to do it, let me write in comments. So what I'm expecting here? I'm expecting a series like 30, 20, 10, 0, minus 10, minus 20. Okay, so these 6 numbers I want to print, right? So see, first thing that we need to understand is whenever we get a problem statement, we need to solve it logically. So logically here I can see that, you know, first integer is 30 and then it is getting decremented by 10, right? It is getting decremented by 10, right? So this is my logic. I'll write it down so that I don't forget it. Start with 30. Keep on decrementing by 10. Decrementing means reducing by 10 every time, right? With every iteration. Okay. Another input that I can have or whatever I can see from here is what I have to do, run for 6 times. Why? Because I want to display 6 values. I can keep on going, minus 20, minus 30, minus 40. Right? I can keep on going, but I need to give a term condition. So as per my requirement, my terminating condition is run for 6 times, correct? So this logic we will develop. I mean, it's a pretty straightforward logic. In similar lines, we have to develop this logic. So I know that I have to start with 30. Okay. Spaces won't matter here. Then I want to run it for 6 times. Okay. So let me start with 1. And I want to run it for 6 times. And okay, so I'll design my for loop first to run for 6 times. I know that whatever I write between this block will run for 6 times, correct? Now what do I run to for 6 times? So I'll add one more variable, okay, j, which will be, okay, not call it j, let's call it starting number. So for this problem, the starting number is 30, correct? I have to print it. So I'll say print out starting number. Okay. Now, if I initialize the starting number here, it will always be set to 30 on each iteration. Okay. So I'll set it outside my loop. Okay. I'll set it outside my loop. After printing 30, what I have to do? I have to decrement it by 10. And for every iteration, I have to do it. So I'll say starting number is equal to starting number minus 10. Correct? For every loop iteration, what I have to do? I have to decrement the number by 10. And I will run this loop for 6 times. Okay. So let us see if I get the output or now. Output or not. Yes. So let me scroll the console window. Yeah. See, this is my output, which was expected. And it has ran for 6 times. So what I did here, first I initialize the starting number because I know that my number starts with 30. Then I keep on decrementing 10. So see here, I am keeping it decrementing by 10. Okay. So this is one way. If we want to, you know, introduce or we want to do this logic in the for loop itself, how can we do that? Okay. So I'll write now a program that will do this. There are 2 approaches. So this was first approach. Second approach can be in the for loop. I'll initialize my variable with 30 because, you know, that is what I want to do. Okay. And I want to do this unless my number either is greater than or equal to negative 20. Correct. Because I know that that is my ultimate output, right? If I don't know the number of times my program should go, I will do this, and I can put the condition like I is equal to I minus 10. Okay, so I'll keep on decreasing 10 until I reach minus 20, and as soon as I'll reach minus 20, my loop will terminate. Opening the code block and simply printing I. Okay, so see, here we are saving the effort of initializing a number and all that thing, having extra variables for, right? We can achieve our program similar output by this also. Okay, now if I say commit a minor mistake and I do this sign, so this will be my infinite loop, right? Because this condition will never be achieved. Okay, so I have to be very precise on giving the conditions. Okay, so generally when we are decrementing, we are using I is greater than, and whenever we are incrementing, we'll use I is less than. Okay, so this is a thumb rule which you can remember. Now we wrote, see, in this example we wrote I plus plus here, right? So I plus plus means nothing but, so it means nothing but I is equal to I plus 1. Correct? We saw this in operators class. And I is equal to I minus 10 can also be represented as I minus equal to 10. Okay. So if I replace I is equal to I minus 10, this is a valid condition and this is also a valid condition. Okay, so see, my program will go through with the same output. Okay, so these two are same things, nothing different. The way of writing is different. Java compiler will understand both the things, for loop will accept both the things. The way of writing is different. Okay, so I'll maximize this and I'll freeze this out, and you can go ahead and do this program. Okay, this one, program 2. Okay, so code is in front of you, you can refer this if you like, but if you have to do this program, Aarti, minus 7 to 13. Oh, yeah, so you have to do this program. Yeah, now it must be visible. So you have to do this program, minus 7 to 13. Okay, okay, yeah, you go ahead, do it, and whenever you are done, you can ping me up. Okay, so I'll stop the sharing. You can share it, and we can see the debugging point. Yeah. So okay. Mm-hmm. Okay. So we are saying for loop one. Uh, so you are starting with -7. You are decrementing it by 3, and you are doing it till 13. Uh, Yes, ideally you should get an output. Okay, so can you? Okay, so in my yeah, so I have seen this issue sometimes in Mac, that it doesn't reads the main class, but it is reading now. Okay, yeah. So yeah, you can execute it. Yeah, let's see. So it says error exists in project. Okay, so since you are using the same Techcanvass project and there are errors in com.examples, right? So can you open that? Yeah, com.example. Let us resolve the errors inside it. Yeah, just to open the package by clicking on the small left arrow on the left hand side. No, yeah, to the left. Yeah, a small arrow which is pointing to the right, just to the left of, yes, exactly. Yeah. Okay. So see, there are a lot of errors here which are, prohibiting this main class from getting executed. So what?
Yeah, I think there are some incomplete ones, but earlier I didn't get any such issues that if that one is having error, this will not execute.
Uh,
I don't know.
yes. Yeah. No. I mean, since your project has these errors, so this will. Okay. So can you run it again? I mean, yeah. Can you click on the run icon on the top, the red icon? Yeah. Yes. The arrow to the right of it, small arrow. No. 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 This is for debugging basically. This is for run configuration. Yeah. Close this one. Hmm. Yeah. So yeah, just to the right of this, a little right, a downward pointing arrow is there. No, no, downward pointing arrow, black color in the right of the run button. Yes, this one. Yeah. Now click on the first thing. Yeah, click it. See. Okay. So let's say proceed. Yeah. Let's say proceed. So it is not printing. Okay. Can you maximize this console window? I mean, maybe it is printing, but it is, the console window maybe, is not visible completely to us. Yeah, this one. There is no error also as such. Yeah, let's go to problems window. I mean, if there is any issue. Okay, let's explode the errors. Yeah. Okay, so do we have any errors related to our this class? Yeah, you can check in resource if there is some error related to the current class. No, I think, right? Okay, let's go back to the program class. Let me check it once again. Yeah, double click on the console again. So it will go back to, okay, we are saying here. Ideally, uh, okay. Okay, can you drag this com.loop package to the demo project that we have on the top? I mean, about this. Yeah, let's come to the package explorer. Yes, in the left hand side package. Yeah, then there is com.loop package, right? Yeah, just drag it to the source folder under demo on the top. You can see demo and there is a source. Yeah, just drag it there. Yeah, drag it. Yeah, come. Yes, correct. Okay. No, it's not. It's not gone. Yeah. Once again, we have to try it. Yeah. Drag it on the src word. No. Yes, this one. Correct. Yeah. Leave it there. Yeah. Say okay. Okay. Yeah. Let's now try to run it by closing all other windows probably. Yeah. Let's close all other windows. I mean, yeah, you can keep them open, but just close this for loop PRG one. For loop. Yeah. Close this one. Yeah. Reopen the one which we have. I mean, change the project for. Yeah. Double click this one. Yes. Open it. And I mean, yeah, let's just recheck the code. I mean, there. Okay. Yeah. Let's now execute it. Because there are no errors as well. Ideally, the console output should appear. There might be some issue which is Mac related. Still, we are not getting it right. Okay. So can you go to the, okay, hold on. Just give me 1 minute. Yes. So the reason can be the condition that you have used. See, we are using a condition in the for loop which is never true, right? So the program is getting executed, but the condition is never true. See, initially, what is the value of I? It is -7. And what condition are we checking? Whether -7 is greater than 13. So is it greater than 13? Is -7 greater than 13 or equal to 13? No, right? No. So whatever, no, hold on. So whatever problem statement is saying that first number should be -7, right? So when you say minus I is equal to -7, that code is correct, right? Yeah. Let's say I is equal to -7. Okay. But when it goes in the second, yeah, here, if you see -7, is it greater than 13? No, right? So we are using a wrong operator. Instead of greater than, let's use less than. Okay. Let's use less than operator, but do not run it. Okay. Because it will go in infinite loop. Okay. Let's use correct. Now, the condition I minus is equal to 3 also seems incorrect because we are decreasing 3 from I. If we decrease 3 from say -7, the number would be -10, correct? So it should be plus, exactly. Okay, because our problem statement is saying after -7 I have to add 3. I don't have to subtract 3, correct? Yeah, let's run it now. I mean, when I re-looked at the problem statement, I understood your issue. See, this is what was required, right? So instead of 3, you have to add 4 as per, actual problem statement. You have to add 4. Yeah. So now, yeah, now the output will be perfect. Whatever is there. Yeah. Okay. So up till 13, it ran and it added 4 for every iteration. Okay. So the general thumb rule that I told you, if we are using plus in the increment, we do I less than. If we are using minus, we do I greater than. Okay. So this is the logic, that we need to keep in mind. Okay. Okay, let me, okay, so you can stop sharing and I'll restart it. Okay, so basically you got the idea, right? How to use for loop and what are various aspects of it. Okay, so there is one more assignment here, which is multiplication table. Okay, so program to print largest and small number from array of numbers. Okay, so this is a little complex assignment, but yeah, I believe that you should try it out. Okay, so it's very simple, right? See what we are doing here. We are just multiplying 5 to the 1, 5 to the 2. So 1, 2, 3, whatever is changing, this can be a loop variable, right? And we can simply multiply this loop variable in our code block with a number which is 5. Okay, for 10 times. So it will print the 50. Correct? So you can try this assignment out. Okay, printed multiplication table, simple. Okay, so you can try this out. If you have any questions, we can discuss it in next session. Sorry. Now, while loop. So while loop is also very similar to for loop. Okay, so it executes a block of statement repeatedly until a condition is found. Okay, and the difference is there is no initialization. Okay, initialization is not required, right? We can do the initialization on our need, or I mean, it's optional, right? So the structure is different, right? So the same program, if you want to write of printing numbers 1 to 10 in the while loop, so you will see that the initialization is before the loop here, and count is equal to 1. Okay, then the condition, and then in the while loop block, the code, and then the increment at the last. Okay, so this is very similar to for loop. Okay, just the representation is different. And one point that the one thing that you also tried, I mean, which we were thinking as an error, which was that we were picking up a condition in the for loop which was never getting executed. Correct? So it was always returning false. So in while loop, also there is a condition here, right, which is in the bracket, count is greater than equal to 5. So the content of the while loop, or the code statements that are part of while loop, for example these two statements, will only be printed or will only be executed if the condition is true. Okay, same as for loop, right? So I'll write one program to do the sum of marks. Okay, so our problem statement is that there is an array . Okay, so our problem statement is there is an array and which has some values. Okay, and we do not know how many values are there, but we need to use while loop and we need to print the sum of all the numbers. So what I'll do, I'll right click this, I'll have a new class and I'll say check while loop. Okay, so my problem statement is okay, add all numbers of an array. So my array can be integer. Okay, score. Okay, for I want to add for example I want to add all the scores, and there are say 10, 20, 30, 3 numbers. Okay, for simplicity let's say 3 numbers. Okay, so this is my array score, Okay. Now my problem statement is I want to add all these numbers. So I'll say while. So how do I compute the condition? I don't know the length, right? Because we are writing a program. There can be any number of elements in the score. So what I'll say while score dot length, okay, is equal to null or is equal to 0, right? So until and unless yeah, so no, this is an incorrect condition that I'm writing down here. Okay, so how I will proceed with adding all the numbers. Okay, so one way manually to add all the numbers is, to say that have one addition integer, okay, which will store the addition and say that score 0, correct? Because 0th index is 10, right? From our arrays learning. Score 1 is 20 and score 2 is 30. Okay, from our arrays learning, and we can display the addition one way, correct? But say there are a lot of variables in score, then we will need a while loop. Okay, so for while loop I will have one variable, okay, and also I'll calculate the array length, correct? So what will be my length of array? It will be score dot length, correct? I can use inbuilt Java length integer, which is already there with the score array. Okay. So now I know the length. Okay. It is in the length variable. I don't know the value, but it is in the length variable. Okay. So what I can say now is while length is greater than 0, less than 0, I will keep on reducing the length here, right? And I'll say score of 0, sorry, score of I plus score of I plus 1. Okay, I can say this and I can store this to addition, right? But see, there is one very important difference here between the while loop and for loop that I like to highlight. So see here, what we are doing here is that we are playing on the variable total which we have kept outside the while loop, okay, and we are iterating it for the total length of all the elements. Okay, total length of all the elements means the total length that is available in the elements. Okay, so I'll run it till the length is reached. Okay, so I'm starting with 0, I'm running it till length is reached, and in my program logic what I'm doing is I'm adding I didn't initialize the addition variable. So what I'm doing in program logic is I'm I'll keep on adding the ith index of score array. Okay, so initially the ith index is 0 here, right? Okay, so in the while loop also we know that 0 is greater than 3, right? So if there is no length, it will not execute it, right? If length is 0, it won't come inside this condition, right? And we can keep on doing this, and in the end, after the while loop breaks, so we know that here while loop will break, right? So for that we have to do incrementation. Okay, every time we have to increment the I, and in the sys out I can say addition. Okay, so if I run it, see 60, correct? Because the addition is 60. Now if my this thing changes 70, 80, if I have 5 more, I have a new array, I don't need to change anything, correct? Same program will be usable, right? 80, correct? Because I added 2 more variables, right? If I do -10 and -10, it should go back to 60. Okay, so the length we are, variating the length, correct? Now, how are we doing it? We are storing a length. Okay, first we are computing the length of the array by using this score.length, correct? We are storing it in a variable, and then uh, we are running this loop, okay, for the entire length. Okay, the number of iterations should be equal to number of length, okay, the size of the array, because we have to add each and every number. Okay, and as a temporary variable, we to store the result, we initiated the addition variable, okay, which will keep on adding the length on each index. Okay, so first it takes 10, okay, it's add to the addition 0 plus 10 is 10. In the second iteration it adds 20 to 10. Third iteration it adds 30 to the addition. Okay, so it is keeping on adding until we are up to the last element, which is the length of score array. Okay, so this is the logic that we are applying using the for loop. Sorry, while loop here. Same can be done using for loop as well. Okay. Okay, now there are few assignments like a program to find factorial, program to reverse, and program to find whether the number is a prime number. Okay, so you can try these assignments, but reverse, we know that we can use reverse function as well, but here we will not use reverse function. We'll use the while loop or for loop. Oh yeah, while loop, exactly. Okay, also factorial is, if we are giving 5, so the factorial of 5 would be 5 into 4 into 3 into 2. Okay, so all the numbers that are below 5 up till 1 are multiplied. Okay, we do not multiply 0, right? Otherwise the whole number becomes 0. So we multiply it. If we are giving 10, so it should multiply 10 to 9, then the result to 8, then the result to 7, right? Very similar to the addition program that we wrote. We just have to multiply it instead of adding it. Okay, now the third loop, which is a do while loop. So do while loop is same as while loop with one difference. No matter the condition is false, loop will be executed at least once. Okay, so in the example that you did for loop, the condition was false, and in case of for and while loop, if condition is false in the first iteration, nothing is executed. But in do while loop, even if the condition is false, the code is executed at least once. Okay, so here we say that loop is executed at least once, because what we do, first we execute the statement, then we compute the condition. So this is the point to remember, that first we execute the statements, then we compute the conditions. So a program to find, validate password, allow 3 attempts to enter password, message of account is locked after 3 wrong attempts. Okay, so okay, let us write this one down, or let us do this program using do while loop. We'll say check do while loop. Okay, so first we will take the password. We'll say string password is equal to whatever password you want to pass, right? Like new password. Okay, then we'll check in the do while loop, do, okay, and while. Okay, so this is the syntax of do while loop, right? So we will say here, if password, we are comparing, right? So we'll use double equal to, we are not assigning, is equal to new password, then print You entered right password, right? Else we'll say incorrect password. Okay. Now before exiting the loop, I'll increment the number. Okay. So see, here, whatever the password value is, this loop will be executed once. Okay. We can take this from user as well using scanner class. So we can say scanner n is equal to new scanner system.in, and we can say okay, we can read this from user. Okay, so we are giving 3 tries unless and until users enter this. Okay, otherwise we'll keep on printing incorrect password and we will keep on telling to him or displaying to him that he's entering the incorrect password. Okay, so this is a simple program to check the password. Now if I run it, yeah, so okay, let me make it a little better by passing a friendly message saying enter. Otherwise we don't know where to enter password, right? Okay, so it says enter password. I say test. I know it's wrong password, right? So it says incorrect password and terminates. Now see, enter password, it is just took the password once and then terminated abruptly, right? So to handle this, I have to pass it inside do while loop, right? If I have to do it every time. And I'll remove this ln so that password it takes in the same line. So I'll say enter password. If I say password is test, it says incorrect password and asks for password again. Correct? If I say test1, again incorrect. Okay. If I say test again incorrect, right? And after this, the program is terminated, right? Because we allowed only 3 retries, right? We allowed it only 3 retries, right? And if I enter the correct password, see, there is an issue here. I'll tell you what is the issue. If I enter correct password, it is still asking for, I mean, it is still not able to figure it out. Why? Because double equal to operator cannot be used with objects, correct? So we have to use dot equals. String is an object, right? String is a, if there are numbers, we can use that double equal to, correct? Now there is one more issue, I'll tell you. So if we do this, it's asking for password. If I say correct password, which is new password. So this is right, correct? But see, it is again asking for password and program is not terminated, right? Or the control is not gone to other things, correct? So it should ask for password only if the password is incorrect, right? So in loops, we need to have something that we should break the loop, correct? We should have some provision to break the loop. So that provision is the break keyword. So what we can do, I will say if password is guessed correctly, break it, correct? So if password is guessed correctly, then only it will come to this if statement, right? And it will break it. Okay, so let's check the incorrect combinations first. 3 retries. Test 1 incorrect, test 2 incorrect, test 3 incorrect. Okay, and it exits. Okay, see, the program is terminated. Now the correct one, new password. Oh, messed up. Let me rerun. It says enter password. I say new password, which is the correct one, and you entered the right password, and the program is ended, right? The break statement is executed. We do not want to run loop again and again if we enter the right password. Okay, for example, in first iteration, I'll enter new, which is incorrect. Then I enter the correct password. Okay, so the program terminated. As soon as you enter the new correct password, the program terminates. So basically in do while loop, the difference is that the whole statement will be executed once, even if the condition is false. Okay, for example, I'll do the false condition. For example, I'll say I is equal to 9. Okay, and I run it. So even if I enter correct password, it won't ask for retry. See, it is running once. Correct, I'll say new incorrect password, and program terminates. Why? Because the initialization, I made a mistake. Correct, but see, if you make mistake in for loop, like we saw some time back, it was not executing even once. But if you make this mistake in do while loop, this will be executed once. Okay, the code block will be executed once. Okay, so this is the example of do while loop. Okay, and how we can handle the password. Of course, this string can come from a database, right, in a real world, but this is how it can be done. And number of retries can also be configured here. Okay, I can say this as number of retries, and I can say integer number of retries is equal to 3. Okay, so if I don't want to change the code a lot, right? So I'll take it outside in a variable, right? So see, this will also work for 3 times. Correct, and the program terminates, right? So if I want to change the number of retries, I just change here. I don't want to look anywhere else. I say 8. I run it. Oh, sorry. Okay, so I'll say 1 incorrect, 2, 3, 4, 5, 6, 7, 8. Okay, and the program terminates. This is terminated, right? So this is the way we can program Java effectively. Okay, now program to list out leap years. So we know that after every 4 years there is a leap year, right? So you can write this program, you can do this program where you will enter a year and you will enter a second year, and between those 2 years, whenever there is a leap year, it will be displayed. So you might have to use modulus here. Okay, you can divide by 4 if modulus is 0. You can call it as a leap year. If modulus is not 0, you can call it as a non-leap year and not print it. So this is a hint. Okay, you can go ahead. So I hope you write or do at least one assignment each of for, while, and do while. Okay, so with this, we are in a place in Java where we can safely start or safely migrate towards Selenium. We know arrays, we know if statements, we know for loops, we know operators, variables. Okay, so basic things we know. Correct. Now it's high time we should look into some basics of test automation. Okay, so we will start that today. because I want to spend a lot of time in hands-on of Selenium and the project that we want to do. So the project that we'll do, I'll introduce the project. This is the the diabetes management system that we will automate. Okay, so see, there are various screens here. Let me start it from beginning. So this is the home page. Okay, so we can we can automate login, reset, everything we can automate here, right? We'll see how to automate it, how to drive the UI using Selenium. Okay, we'll use Java for it, and the learning that we have done is will be of use here. And whatever we have learned, the basics of all that thing we will be using here to understand how to automate using Java. See, there are various fields. We will fill data in them. We'll submit the forms. Okay, we'll click the buttons, like add button is there, correct, or the save button is there, right? And then we will read the data. We'll check, we'll check things like, we'll test things like when we click on OPD homepage. So is the home word displayed? Is welcome Parandena, welcome, the username is displayed, search patient is displayed, right? Or we can also test that if I say any string and I say show all, so what results are displayed, right? So we'll automate some use cases, and some use cases you can try on your own, and if you have questions you can ask for them, right? But today let us start with introduction to automation testing, because Java basic things we have already covered. Now, before diving deep into what is automation testing or how to do it actually, let us first understand some concepts. So why do we need automation testing? Every project there is a frequent regression testing cycle, right? There should be at least a frequent regression testing cycle. And if keep on regression test the software manually, it can eat up a lot of time. It can be time consuming. It can be resource consuming. It can be frustrating also sometimes, because you are doing a lot of redundant work, correct? And in regression, the probability of finding issues is there, but is relatively less when compared to other forms of testing like functional testing, right? In functional test, we have a very high probability of uncovering the defects, but in regression, we do not have we can uncover the probabilities relatively less. Second, rapid feedback to developers, right? So you can very quickly run your regression suite, and you can appraise developers about any bugs very, very quickly, because manual testing, if you have to execute say 1,000 test cases, you might end up testing for months, and then you can report the bugs, right? So this is automation makes things very quick. Virtually unlimited iterations of test cases execution, right? We can execute same test case any number of times. With industry moving towards agile, and there are extreme development methodologies that are going in place, it is very necessary to keep on retesting the application under test many times using automated regression testing, correct? Discipline documentation. By discipline documentation, we mean that as soon as we convert a test case to a test script, it is documented in a way that it can be executed anytime. And ideally, our test scripts should be atomic, and they should be prepared in a way that they can be executed on a standalone basis as well, right? And each script should have some test rationale or test goal behind it. Okay, so this is the basic of test automation. Each test script should have a test goal or rationale associated with it. Customized defect reporting. We can roll out a mechanism to report defects very quickly, because automation will uncover issues for us based on the manual test cases that we automate. Finding defects missed by manual testing. So if there are a lot of data combinations, if there are a lot of screens to be verified, Okay, so in testing, we applied methodologies like boundary value analysis or equivalence partitioning. Despite of that, we might miss some corner case, which we can, quickly automate and run it by changing some small level of data, right? So such issues can also be uncovered by test automation. Now, this is an important question to when to automate and when not to automate, correct? So we should not automate if my application is changing very, very frequently. Frequently is incorrect because nowadays, applications are changing frequently. But if it is changing very frequently, say it is, changing twice a day, or, if developers are making changes every day, we should not automate until there is some level of stability in the application. Okay, otherwise it will involve a lot of rework. Not enough time to build automation scripts. If there is no time, no budget, we should not automate. Okay, an application has a tight deadline, so we should appraise this risk to the stakeholders. That application has a very, very tight deadline. So test automation won't be possible because test automation, initially eats a lot of time when compared to manual testing. But for longer running projects, it is beneficial because the time you spend initially in automating the test cases is saved, 10 times, tenfold times, because you don't have to execute them manually every time, right? So it depends on the circumstances also. Now, advantages: reliable. So it eliminates human error. So the important thing to make an automation script reliable is to have a complete knowledge about tool and technology that we are using, right? Because if you have, if you don't know the things and you go ahead and do the test automation of any script, you will end up making an incorrect script, which will be not reliable. So automation testing has an advantage of reliability, but the responsibility of engineer whoever is automating the test case, it is that he should make the automation test and he should thoroughly check it again and again before committing to a fact that the automation script is ready and it serves the testing goal, right? Each automation script has a test goal. Reusable. Every test automation script should be reusable. It should be atomic. It should not be dependable on any other aspect. Okay, for example, test data, right? So a test automation script ideally should be capable of handling the test data or read the test data from any source or resource. Better quality software, since we are testing again and again, we are testing same scenarios, the probability of uncovering defect is maximum, right? And important scenarios we can run multiple times a day. With every check-in of the developer, we can run multiple tests automatically, by just a single click of button. So this ensures better quality software. Test automation is fast, correct? Because when we say fast, it doesn't necessarily means that test is executed in, say, the complete application is tested in 10 minutes. But if you think of fast, you can run many test cases overnight, right? It can take 6 hours for manual testing and say 4 hours for automation. Okay, so the time saving is just 2 hours, but the test can run overnight, right? The automation can run overnight, but manual testers cannot work overnight, correct? Also, there can be multiple instances and tests can be divided in multiple suites. Parallel execution can be achieved, right? But if we test something manually, we can't test parallelly, right? Because one tester can work on one feature. You need more resources if you want parallel execution. But if you have test suites automated and segregated in a defined manner, you do not need many testers. You can create multiple instances of your test automation framework and you can execute different test suites, correct? So this should be a feature of test automation framework, that it should support parallel execution. Cost reduction, since you do not need to add manual testing resources, right? So it reduces the cost. Moreover, every automation suite saves a lot of time when compared to manual execution. So it saves time, it saves resources, right? Human resources. So cost reduction, right? But again, when we look into the disadvantages, we'll see the impact of cost going on a higher side. So first impact is high investment needed in tools and training. Okay, so you need proper automation tools. Selenium is free, right? But you need training, you need ramp up, right? Companies also have to invest in training. They have to hire trainers, maybe, right? Or resources. Whoever are ramping up, whoever are studying Selenium, they are being paid salaries and whatever for learning job. So this is the cost that is associated with the automation training, right? But advantages is, uh, advantages anytime overrule the disadvantages. High manpower requirement for preparation. So so high manpower is skill, right? You need skilled test automation engineers who are, capable like developers to prepare test automation frameworks, right? Who have knowledge of test automation tools and language, both. Correct? So see, we started learning Java and now we are migrating to Selenium. So knowledge of language is also necessary. A lot of testing areas are left uncovered. So everything cannot be automated, right? Anyways, at the end of the day, you need something manually to be tested. Manual testing cannot be replaced by automation, right? Because there are some scenarios which are first, which do not make sense to automate. Second, which cannot be automated due to limitations. Now levels. Now see, when we say levels, there are two types of automations: UI driven and code driven. Okay, so a UI driven or a UI level is based on keystrokes, mouse clicks, UI controls. Okay, and code driven is testing at source code level with a variety of input arguments, right? So we can say that, we can test the API and we can test the UI. Now UI driven automation. So is automation testing that people are talking about is usually performed by testers, right? For example, if you are testing a Gmail web app, right? Gmail is a web application, correct? It's an email application. So you will test various features like compose an email, send an email, delete an email, archive an email, right? Or add an attachment, compose an email. So you will be testing many features, right? So in UI, automation tool interacts with software under test via UI object properties, correct? For example, on Gmail, the compose button has some properties, right? And the SUT or the AUT, the software under test or the automation, the service under test or the application under test is a Gmail, right? So UI has an object, which is a compose button. It has few properties and my tool will interact using those properties, right? This is the crux. Our tool interacts with the application using a properties, right? Which developers have developed. Image-based automation tool interacts via image recognition. Okay. Image can have properties as well and image can be recognized as well. Now, code-driven test automation or API-driven test automation is usually performed by development team, okay, which is done by a unit testing or JUnit, using JUnit and unit, using such tools. Also, nowadays, approaches are coming up like TDD, which is test-driven development. In this, developers first write tests and fail them, because without code, tests will fail, right? If a Gmail developer has not written code for compose button, the test will fail, correct? But what developers do they write the test first, make them fail, and then they develop the code such that each test is passed. Okay, such that each and all tests are passing. They develop a code such that all tests are passing. So it is code-driven test automation is promoted in agile software development. Okay. So unit tests are developed before the code is written. So obviously they'll fail, and then code is written so that all tests are passing. This is TDD approach or JUnit approach. I covered it quickly because that has very less relevancy for us. Okay, moving ahead, test automation tools. So there are various tools. So on the left hand side, you will see the tools that are licensed tools, and on the right hand side you will see the tools, those are free tools or open source tools. So this is pretty self-explanatory. QTP, IBM functional tester, test complete, ActPlant, SOAP UI Pro version maybe is the tools which are paid tools. QTP is now UFT, Unified Functional Tester, ALM, right? So these are paid tools. They are very easy. You don't require much coding skills, right? And they're very easy, self-explanatory. Lot of help available, lot of community forum available. But overall, software industry is moving away from these paid tools due to high license costs. Okay, so disadvantage, very costly, lack of customization, right? They do not give you their source code, so you cannot customize and you cannot integrate with other tools, right? Free tools or open source tools. Selenium Water, it is spelled as water, but it is pronounced as water. Okay, the water that we drink, or water, regular water. So Selenium Water is a Ruby implementation of Selenium. Selenium can be used with Java, C#, Python, Ruby, many languages. Robotium, JMeter, Appium, Selenium, many tools are there. JMeter, SOAP UI free, SOAP UI Pro. There are two versions. So SOAP UI free is for API testing. JMeter is again for API and performance testing. Robotium, mobile, Selenium, APM are also for mobile application and mobile website testing. Water and Selenium are for UI browser website testing. Okay, so they do not test applications, Selenium and Water. Selenium generally tests web applications and websites. Okay, whatever you can access via a web browser like Chrome. Okay, so this is important. Selenium cannot test desktop applications like calculator. Okay. Advantages are free, can be integrated with other tools. Disadvantages, first disadvantage, I would say that, later turns as an advantage and, later turns as a boon basically, is that you need to know some programming language. But nowadays, Selenium is so matured that you need to know only very, very basics of programming, right? So in Java, we have seen very basics of programming. We'll use it practically to develop a complete test automation framework for the diabetes management portal that I've shown you, right? It is a full-blown application, and we will automate together all the scenarios, and most of the scenarios, and we'll learn the crux of test automation. Moving ahead, mobile APM, yeah, I told you, Cylindroid, Calabash, I haven't heard that, but yeah, Calabash. Okay, so native apps and web apps both can be automated using the mobile automation tools. Okay, going to the future, this is very relevant since Agile is coming. So automation is a must. Without automation, I don't think any organization, any major software vendors or service providers are, playing ahead. They all are focused a lot on test automation. And test automation is need of the hour. If you cannot be a truly agile or even partially agile if you are not automating. Assignment, I wonder what will be the assignment. Yeah, no assignments. So this was the introduction to automation testing and why should we do this. Okay, so I think we can wrap up today's session because already it's time. And in next session, Aarti, I'll request you to try those 3 assignments, at least 1 assignment each for each loop. Okay. And next session, we will look into the introduction of Selenium. Okay. So it's an important session. We'll have it tomorrow. Okay. And I'll introduce Selenium and maybe we'll write some scripts. So now, the interesting things will start because, the interaction with UI and applying the knowledge, right? So even if we are aware about the Java terminologies and we cannot program, you will find it very easy to automate test scripts using Selenium WebDriver. Okay, so tomorrow we'll start, and tomorrow, since tomorrow, the interest or the uh, main functions of Selenium testing starts, right? So we'll keep it interactive, and yeah, it will be interesting. So see you tomorrow. Yeah, sure. Okay, I'll share the recording with Pranita and Gitesh. So Pranita, are you there? Okay, Aarti, it seems Pranita is not there. I'll call her on mobile, and in say 1 hour maximum, you will. I'll ask her to send the recording. I mean, it will take me 1 hour to convert it, and upload it to Google Drive. Approximately 1 hour. After that, this recording would be available. And do you have access to these PPTs? Course PPTs, do you have access to them? Okay, please check it, if because they have assignments, right? Please check it. If you don't have, please drop an email to Gitesh and Pranita and ask for access to these PPTs. Okay, yeah, yeah.